Hello students, welcome to physics class. Today's video we are going to learn the another one property of fluid from the unit 7 properties of fluids. Students, have you wondered about the water striders walk on the water? Do you know what is the reason? All right. When the water comes or falls on the surface, it becomes spherical in shape. Have you wondered about that? That is, when the raindrops falls on the surface or fall on any leaves, it becomes spherical in shape, isn't it? Do you know what is the reason for this? Yes, the reason behind these examples are surface tension. Today we are going to learn surface tension. In today's video, we are going to understand the concept of surface tension. Also, intermolecular forces, surface energy and its unit, then factors affecting the surface tension of a liquid, then the surface energy and surface tension expression. Okay. We know that the liquids, solids have definite shape, but the liquids have no definite shape but have a definite volume, isn't it? Yes. So when we pour the liquids in a container, it occurs the shape of that container. When we pour the liquids in that container, for example, in a tumbler, if you are filling that water, top surface fully it will be stayed. When we pour more amount of water beyond the surface of the tumbler or that container, the water falls. But at that certain limit, the top surface, the water in stable equilibrium. Isn't it? That is actually due to the surface tension. Let's see that. So when the liquid poured in a container, they occur a free surface on its top. Okay, so therefore the surfaces have some additional energy called as surface energy. The surfaces have some additional energy. It has to be in that stable position, that is called as surface energy. This phenomenon is called surface tension. So let's define the surface tension. Surface tension of a liquid is defined as the force of tension acting on a unit length. The force of tension acting on a unit length of an imaginary line drawn on the free surface of the liquid. The direction of the force being perpendicular to the line so drawn and acting parallel to the surface. So what is surface tension? It is the force acting on the surface of the liquid. Actually, it is the force of tension acting on a unit length of an imaginary line drawn on the free surface of the liquid. The direction of that force being perpendicular to the line so drawn and acting parallel to the surface. This is about surface tension. There are two scientists, Laplace and Gauss. They developed the theory of surface and motion of a liquid under various situations. Let's see in detail. Before going to understand the molecules at different level of the liquid, we should know the intermolecular forces. The intermolecular forces, cohesive force and adhesive force. Cohesive force and adhesive force. What is cohesive force? The force between the like molecules which holds the liquid together is called cohesive force. The force between the like molecules which holds the liquid together is called cohesive force. That is the force of attraction between the same between the molecules of same substance. The force of attraction between the molecules of same substance, that is only the force between the like molecules which holds the liquid together, is called cohesive force. The next one is adhesive force. When the liquid is in contact with a solid, the molecules of the solid and liquid will experience as an attractive force which is called adhesive force. That means the force of attraction between the molecules of different substances. When the liquid is in contact with a solid, different substances, liquid and solid, the molecules of these solid will experience as an attractive force which is called adhesive force. Understand? So cohesive force means the force of attraction among the liquid molecules. Adhesive force means the force of attraction between the liquid and the solid molecules. Okay? So this is about the two intermolecular forces. These intermolecular forces will be effective only when the distance between the molecules is of the order of 10 angstrom or 10 power minus 9 meter. The intermolecular forces are effective only when the distance between the molecules of the order of 10 angstrom or 10 power minus 9 meter. Not so long distance, very small distance only the intermolecular forces will be effective. One more concept, sphere of influence. The distance through which the influence of these molecular forces can be felt in all directions constitute a range and is called a sphere of influence. Okay? The distance through which the influence of these molecular forces can be felt in all directions constitute a range and is called a sphere of influence. Around the molecule, at what distances the molecular forces will be effective. That range we can call it a sphere of influence. So these are the terms we have to understand. Cohesive force, adhesive force, and the range when the intermolecular forces will be effective, and sphere of influence. Now let's understand the surface tension concept in detail. Let us consider a container which is filled with a liquid. Here we are going to consider three different molecules A, B, C. Okay, let's consider this as a molecule A. Now this is another molecule B, and this is another molecule C. Consider this A molecule. This is actually well inside the liquid. Am I right? Yes. So this molecule interacts with interacts in all directions. This molecule interacts with all other molecules in all directions, isn't it? So what is that? Net force experienced by this A is 0 because it is very well inside. Here the molecules are there, here the molecules are there. So everywhere this molecule will be getting attracted and interacted. So the net force experienced in all directions by this A is 0. Now let's consider this B molecule. This B has more molecules in the downward direction. So that is 3/4 lies below the surface of the liquid and 1/4 of the air. Can you understand? This is actually the surface of the liquid. So 3/4 is below the surface of the liquid, 1/4 is above the surface, that is in the air. Here, this B has an interaction more in the downward direction, isn't it? Because more molecules are in the lower side. The more liquid molecules are in the lower side, right? Than the upper side. So it experiences a net downward direction force. It experiences a net force which is in the downward direction. Similar manner, Consider this molecule C. Here, the upper half is in air, lower half in liquid. Okay. Here also, this is actually air and this is liquid. So, it will interact with the liquid molecules in the downward direction. So, it experiences the maximum downward force because more number of liquid molecules are in the lower part. Understand? So, we can understand that this also experiences a net downward force. So listen, so this container actually liquids means the molecules have little space, not like solid, isn't it? Solid, it is rigidly fixed. But liquid, it is not rigidly fixed. The molecules are not rigidly fixed. So all the molecules experiences a net downward force direction. So the surface of the molecules, that is on the surface the molecules are there, no, that molecules will be attracted by this downward direction. Can you understand? The molecules which are on the surface of the liquid, which will be attracted in the downward direction, and among this surface of the molecule there is an attraction on this line. There is an attraction on this line. So this will be act as a stretched membrane and it is trying to contract the area. It is trying to contract the area. This is known as surface tension. So listen, when any molecule is brought towards the surface from the interior, actually work is done against this cohesive force. Am I right? Because all the molecules are experiences a downward force. So everything will be attracted here, even though among that the molecules which are in the surface will have a bond. So this will be an attractive force here. That means it is trying to contract some area. So it will be stable on that surface. That is known as surface tension. Okay. So it has a particular energy to hold on this part. That is known as surface energy. So here we have to understand one more concept. When any molecule is brought towards the surface, actually the work is done against the cohesive force because all the molecules are same, liquid molecules. The cohesive force is very much. So the molecules are attracted downward. But the work is done to brought the molecules on the surface. This work done is stored as a potential energy. This work done is stored as a potential energy in molecules. So, these molecules will have greater energy, greater potential energy than the molecules which are inside the liquid. Got it? That's why it is in the stable equilibrium. So, when it is in the stable equilibrium, its potential energy must be minimum. Can you understand? The molecules which are in the surface have greater energy, greater potential energy than that of the molecule inside the surface. We know that the molecules which are in the stable equilibrium state. But if it is in the stable equilibrium, what is the condition? The 5th chapter we have understood. Stable equilibrium means the energy should be minimum. The potential energy should be minimum. So its potential energy must be minimum. Therefore, in order to maintain the stable equilibrium, the liquid turns to have a minimum number of molecules on the surface. Understand? So the liquid turns to occupy minimum surface area. This behavior of liquid gives rise to surface tension. Understand? So because of surface tension, the area is trying to contract on the surface of the liquid. Okay, the liquid turns to occupy the minimum surface area, the contracting area. That's why we can call it as the force acting on the surface, that is known as tension, surface tension. Okay, so examples already I explained, that is water bugs and water striders walk on the surface of the water. Actually, the water molecules are pulled inwards and the surface of the water acts like a stretched membrane. These water molecules are pulled inwards, but the surface will act as a stretched membrane. So this balances the weight of this water bus and it can use to walk on the surface of the water. Some other examples are given in your book. Go through that. One is the hairs of painting brush. When it is taken out of the water, it will be cling together, isn't it? You have noticed the brushes will be cling together. This is also because of water films formed on the surface turns to contract the minimum area. Then two more activities also given, that is needle floats on water surface. Also one plastic sheet of paper of boat. That is, take a greased needle of steel on a piece of blotting paper and place it gently over the water surface. Blotting paper soaks water and soon sinks down, but the needle keeps floating. Okay, the floating needle causes a little depression. The force is F due to the surface tension of the curved surface or inclined. The vertical components of these two surface forces support the weight of the needle. Now, the add liquid soap to the water and stir it, we will find the needle sinks. Activity 2. Take a plastic sheet and cut out a piece in the shape of board. A tapering and smooth front with a notch at the back is suggested. Put a piece of camphor into the notch of the board. Gently release the boat on the surface of water, and we find that the boat is propelled forward when the camphor dissolves. The surface tension is lowered as the camphor dissolves and produces different in surface tension in water nearby the notch. This causes the water to flow away from back of the boat, which moves the boat forward. So just try these two activities, okay? These are the examples of surface tension. Let's see the factors affecting the surface tension of a liquid. Okay, short answer. Factors affecting the surface tension of a liquid. The first point is impurities. The presence of any contamination or impurities which will affect the surface tension. Okay, the presence of any contamination or impurities which will affect the surface tension depend on the degree of contamination, degree of impurities. The quantity of impurities, the surface tension will be affected. Second one, the presence of dissolved substances. The presence of dissolved substances also will affect the surface tension. For example, when sodium chloride dissolved in water, the surface tension of water increases. Again, phenol is mixed with the soap solution, it decreases the surface tension of water. Understand? So when there is a dissolved substance, the surface tension will be affected. The activity 2, by means of a paper sheet of boat and camphor, the camphor dissolves in the water, it will give the surface tension so that the boat will move forward. Okay, there is a difference in surface tension water, so nearby the knot, so it will be allowing the boat to move forward. The next one, electrification. Electrification in the sense, when the liquid is electrified, the surface tension decreases. Okay, surface tension decreases. When the liquid is electrified, surface tension decreases because the force acting on the liquid surface, which is used to that is area of the liquid surface increases, the contraction which against the contraction, which acts against the contraction, the phenomenon of surface tension, hence it decreases. Since external force acts on the liquid surface due to electrification, area of the liquid of the surfaces increases, which acts against the contraction phenomenon of surface tension. So hence it decreases. Understand? So when the liquids get electrified, the surface tension get decreases. The next one, temperature. Temperature plays a crucial role in the surface tension. When the temperature increases, surface tension decreases. When the temperature increases, surface tension decreases. So these are the factors affecting the surface tension of liquid. They are presence of impurities, presence of dissolved substances, and electrification, then temperature. Listen, for a small range of temperature, the surface tension at T degrees Celsius, we can written as, usually the surface tension is denoted by a symbol called T. I am explaining the next topic. Anyway, the surface tension will be denoted by T. Here, for a small range of temperature, the surface tension T at T degrees Celsius can be written as T is equal to T0 into 1 minus alpha T. Understand? T is equal to T0 into 1 minus alpha T, where T0 is the surface tension at 0 degrees Celsius. T0 is the surface tension at 0 degrees Celsius. Alpha is known as the temperature coefficient of surface tension. Okay, temperature coefficient of surface tension. Here we have to note one more point. At a particular temperature, the surface tension becomes 0. Because temperature increases, surface tension decreases, I said, isn't it? So at a particular temperature, the surface tension becomes 0. That temperature is known as critical temperature. Critical temperature. The critical temperature of water is actually 374 degrees Celsius. This is the critical temperature of water. At this temperature, surface tension becomes 0. So Van der Waals suggested that a relation between the surface tension and critical temperature. Van der Waals has suggested that the important relation between surface tension and critical temperature, that is T is equal to T0 into 1 minus T by Tc the whole power 3 by 2. Here capital T denotes the surface tension, small t denotes the temperature. Understand? So temperature at T degrees Celsius is equal to T0 in 1 minus T by Tc the whole power 3 by 2. T0 is the surface tension at 0 degrees Celsius. Alpha is the temperature, sorry, here there is no alpha. T is the temperature. Tc is the critical temperature. So generally we can written as T is equal to T0 into 1 minus T by Tc the whole power n. Okay. So n varies for different liquids. N varies for different liquids. Understand? Now let's see the exact definition of surface energy and surface tension. Already I have explained about this concept. Actually, when there are molecules on the surface, it will be pulled downward because of the net downward force, but there is a work done to bring that molecules on the surface against this downward force, isn't it? So in that time, it will be in the stable equilibrium. If there is a stable equilibrium, the potential energy should be minimum. Actually, the water on the surface will have greater potential energy. So in order to be the stable equilibrium, the liquid turns to minimize that area. The liquid surface turns to have a least surface area. Okay. So to increase the surface area, some molecules are brought interior from the surface. So work has to be done against the force of attraction. That work done is stored as a potential energy. Actually, the molecule lying on the surface have greater potential energy than the other molecules. The excess energy per unit area of the free surface of the liquid is called surface energy. Understand? Surface energy means what? The excess area. The molecules lying on the surface possesses greater potential energy than the other molecules. This excess energy per unit area of the free surface of the liquid is called surface energy. In other words, work done in increasing the surface area per unit area of the liquid against the surface tension force is called surface energy of the liquid. Let's understand by the formula. Surface energy is equal to work done in increasing the surface area. Work done in increasing the surface area divided by increase in surface area. Okay, the surface area, increase in surface area per unit area of the liquid. That is, surface energy is equal to work done in increasing the surface area divided by increase in surface area. It is denoted by W, work done divided by increase in surface area, delta A. This is known as surface energy. So what is the unit of this? Yes, work done unit is joule and area unit is meter square. So meter raised to minus 2. Or else we can write Newton meter raised to minus 1. Okay. That is work done. We can written as Newton meter. Then area meter square. So on meter may get cancelled. We can write Newton meter raised to minus 1. The next one, surface tension definition. Surface tension of the liquid is defined as the force acting per unit length. Understand? So surface tension, it is denoted by the letter as T. T is equal to surface tension of a liquid is defined as the force acting per unit length of the surface of the liquid. That is T is equal to F by L. F by L. So what is the SI unit? We can write it as Newton meter raised to minus 1. This is the unit of surface tension. So what is the dimensional formula? That is MLT raised to minus 2 divided by L. So L get cancelled. The dimensional formula for surface tension is MT raised to minus 2. Understand? So this is about surface energy and surface tension. Surface energy is W by delta A. Surface tension is F by L. Let's see the relation between surface tension and surface energy. The relation between surface tension and surface energy. Consider a soap solution. In that soap solution, we are going to dip the rectangular frame of wire. Okay. So the rectangular frame of wire, that is A, B, C, D has taken. This is A, this is B, or this is B, this is C, and this is D. Okay. So rectangular frame of wire A, B, C, D in a soap solution has taken. This AB wire, actually it is a movable wire. Okay, this AB wire, it is a movable wire. So when it is dipped in a solution, soap solution, the soap film is formed. That means which pulls the wire inward. That AB pulls the wire AB inward because of surface tension. Can you understand? So when we dip this wire in the soap solution, there will be a frame. Soap film is formed. So that will be pulled inward. Pull inward to the surface tension. So let's write the force due to surface tension as F is equal to surface tension formula. We know that T is equal to F by L. So from this we can write F is equal to what? T into L. Am I right? So F is equal to T into L. Here we can write as 2T into L. Why this 2T into L? This 2 is for two free surfaces because we are introducing in the soap solution. So there are two free surfaces. One is with air, another one is with the film and the solution. So there are two free surfaces. So we can write F is equal to 2T into L. Understand? Actually the length, this is considered as length L. Now suppose this AB is moved by a small distance delta x. Okay, suppose this AB is moved at a small distance delta x. The new position is actually A dash B dash. A dash B dash. This we can consider as a x distance and this is delta x. So what happened? The area increases. Area increases in the sense at beginning this much area, now the area increases this much, isn't it? So the work done against this inward force can be written as work done. W is equal to force into displacement or distance. So here the force is surface tension force 2T into L. What is the distance? Delta x. This is the work done. What is work done? Work done W is equal to 2TL into delta x. Now, what is increase in area? Increase in area, that is delta A. Increase in area delta A is equal to, what is that? 2L into delta x. How it is 2L in delta x? Actually, rectangle area is length into breadth. Am I right? Length into breadth. The length is actually delta x breadth and the length. Length we can consider as 2L. 2 surface. So 2L into delta x is the increase in area of the film. Length into breadth. So 2L into delta x. Now let's find the relationship. What is actually surface energy? Surface energy formula is work done in increasing the surface area divided by increase in area. Am I right? Work done in increasing the surface area divided by increasing surface area. So what is work done? 2T L delta x divided by what is increase in area? 2L into delta x. Okay, 2L into delta x. Now 2 get cancelled, LL get cancelled, delta x cancelled. Now the answer is T. So what is that? Surface energy per unit area of the surface is numerically equal to the surface tension. Surface energy per unit area of the liquid is numerically equal to the surface tension of the liquid. Understand? So this is the relationship between surface tension and surface energy. Surface energy per unit area of the surface is numerically equal to surface tension. Okay students, today we have seen about the concept of surface tension. Some examples and intermolecular forces, cohesive force, adhesive force, sphere of influence, then factors affecting the surface tension, then definition of surface energy and surface tension, its unit, then relationship between surface tension and surface energy. I hope you have understood today's class. Actually, there are two questions in the book back. Define surface tension of a liquid, mention its SI unit and dimension, short answer. And how is surface tension related to surface energy? Maybe 3 marks they can have. So these two questions learned. And cohesive force, adhesive force, factors affecting surface tension of the liquid also learned. Thank you students.